So what I want to do today is talk a little bit about the business perspective, and how machine learning is being understood, is being uh, perceived by companies. And there's a whole lot of misconceptions, myths, etc. in this perspective, and this is why I wanted you to I wanted to open the seminar today with something like this. Okay, so let me start by defining. I mean, it's easy to define what machine learning is, since we have a bunch of bright people coming up with all sorts of models like this one. This one is from MIT, from Karen Howe. It's pretty recent. This is just one of a simple flow chart that allows you to understand whether you're using AI or not. I mean, when basically you're using AI when you're looking for patterns in massive amounts of data, and then whether, I mean, it depends on whether you're using different techniques, I mean, or not. I mean, if you're using massive amounts of data and trying to find patterns, you're using machine learning. If you're telling your algorithms what to look for, okay, this is one set of techniques. If you're not telling, it's a different type of technique, supervised versus unsupervised learning, etc. So it's easy to know whether you're using machine learning or not. So what I want to start with is with a little personal example. A personal example that happened to me a while ago, like a year and a half ago. I was here at home. Early morning, I woke up in the morning. In those days, about a year and a half ago, I used to sleep not much. I used to sleep 5 hours or so, and I was pretty much okay with that. The days were long for me, and I could profit from these long days doing a number of things. But it was my normal situation, and only a few friends of mine used to complain. When, for instance, when I was falling asleep in the middle of the dinner or something. But besides that, besides this issue with my social skills, pretty much everything was normal. That day, I remember I woke up early in the morning. I went to bathroom and then used a course. And what happened? I started to feel weird. I started to feel like my heart was not okay. It was like accelerating. And I looked at my watch, and I quickly realized that the something was not going well. My heart rate was like 140 or something, and I was perfectly relaxed, not exercising, not doing anything in particular, but my heart was 140, real fast. And so after a moment, I looked at my watch again, and it was like 70 or 90, or it was arrhythmic. So I remember at that time, I remember I had this little device I'm showing you, this Vive device at home, because a company, since I'm a blogger, a company had sent it to me for me to check it out. Yeah, I had checked it out a couple of times just out of curiosity, but it was there in a drawer. So I said, I thought, okay, let me give it a try. Let me see what's going on here. And I checked it out, and I immediately realized, as soon as I put it on, this was the reading. The reading said that there was something wrong with my ECG, with my electrocardiogram, and apparently there was some sort of issue I was undergoing atrial fibrillation. Apparently, if you check out the graphs I got immediately with that little device, it indicated that there was something wrong with a couple of parameters in my PQRS wave. So you can check out more things. You can see more analysis. I could see here that something was clearly going on, because this data, this cloud here should be very grouped, should be all together. And here you can see a very sparse pattern. All the dots are all over the place, very dispersed. So there was clearly something going on, and the analysis here in Spanish says there's a suspect of atrial fibrillation. Obviously, no simple device, home device, is going to tell you you are suffering atrial fibrillation. No, it's a suspect, but the suspect was pretty much well funded, very, very trustworthy. So what I did basically was, well, I mean, first I made a little stupid decision, like thinking, hey, I can continue with my life. I remember that day I had a meeting at noon. I was and I was thinking, well, maybe I can, this thing will I will forget about this thing. I can continue with my life. And of course, the smart person in the family, my wife, she said immediately, forget it. I'm taking you to the hospital. So she took me to the hospital. I entered the hospital nearby my home. I entered there, and I told the person, wait, the person in the hospital, yeah, hello, good morning. I'm suffering atrial fibrillation. She looked at me like, yeah, right, as if you could know. And yeah, she quickly funneled me over the triage area, and they took an ECG and immediately said, yeah, you're suffering atrial fibrillation. Of course, I told you. I told you, yeah, and my little device at home said so. So, well, everything was. I spent like 24 hours in the hospital. They stabilized everything with just a couple of drugs, and everything went back to normal. So, and I was thinking, hey, look at this. I mean, I can diagnose myself with a little device. And this was just the first device. After several exams and follow-ups with my cardiologist, I ran into a second device, the Kardia device. The first one is a device from Hungary, from a Hungarian company. It's not yet FDA approved, but it's very good. It's a very interesting device that gives you a lot of information. This one is far simpler. It's American and it's FDA approved. And it's one of these devices that has managed to get the approval of the FDA. They have this idea of well, you have an app and you put your 2 fingers on each pad, and you can quickly put together or see in 30 seconds, you can see your ECG. So I started to use this very often, particularly since my cardiologist liked this one particularly. He was very keen on this device, and well, I started using it a lot. And then I realized that it was not only the first ECG device cleared by the FDA to detect 3 different types of arrhythmias, but also that interestingly enough, it was beating cardiologists, doctors in diagnosing atrial fibrillation. It was doing 4 times better than doctors when it came to detect this type of problems, this type of heart problems. Okay. Well, I continued researching, and I found the device that you probably all have in mind, the by then new edition of the Apple Watch, the Apple Watch 4, and the Apple Watch 4 incorporated another possibility that was they sensorized the crown of the watch, so you could take an ECG just by placing your finger on the crown of the watch. So you would give the watch the opportunity to measure two different sensors, one in your wrist and another one in the crown, and by doing so, you could take an ECG in 30 seconds. My cardiologist didn't like this particular device. He said the Kardia is better, the Kardia is more trustworthy, etc. But as soon as I started checking it out, I realized what was the difference. The main difference, obviously, is that you use your Kardia device or whichever device you have at home only when you feel that something's gone wrong. Only when you feel like you're short of breath or you're unease in terms of how you perceive your heart, etc. There's another family of devices that are even more accurate, and those are the devices that doctors use. The real ECG machines normally have 12 different sensors that you attach in different parts of your body. So for cardiologists, understanding that a device like a Kardia or a Vive device can get as a very accurate measure of an ECG was, in the first time, a big challenge. Then evolving to see that you could wear just a simple watch and get an ECG whenever you wanted was even more challenging. And what happens? What's the real difference? The real difference is that well, you only use an ECG device, a true ECG device from a physician, from a hospital, when you have your revision, when you go for a checkup or something like that. Might be, I don't know, once a year, sometimes less than that, okay? If you have the device at home, you can use it any moment you want, but it's, unless you feel you're worried about it, it's not really typical to get a checkup with this device more than, I don't know, once per month, or every now and then, once in a blue moon, etc. But when you're wearing the watch, what happens? Well, the difference is clear. You're wearing the watch all the time, so you're generating way more data, a lot of data. You're generating data about your heart rate every single moment, whenever you're wearing the device. Okay, so if you're wearing an Apple Watch, probably you might be taking it off, I don't know, while you shower or while you sleep, etc., something like that, to get it charged. But that's pretty much it. The rest of the time, this is registering your heartbeat all the time. So what happens? Well, anyone with a little knowledge of statistics could tell you that what you're doing is playing with the standard error. The more data you throw into the distribution, the better your errors, the more you reduce your errors. So what happens? What's the future? Well, the future is probably going to be something that will change the way we perceive healthcare right now. The future is going to be something, a situation in which, and think about it under the light of the current pandemics. Think about a situation where all of us could be measuring a bunch of different variables all the time, like your heartbeat, your temperature. For instance, there's devices like this one. This is a ring, an Oura ring, and Oura rings allow you to get information about many different things. Well, first of all, your heartbeat, and second, your temperature, your body temperature. What would have happened if, when this pandemic was starting, we have had a wide number of people using something like this and being able to get the measure of their temperature all the time on a normal basis? Okay, we could open source something like this and get to a future in which your devices are putting all your data together and being examined, probably not by a doctor, because you wouldn't have enough doctors, but you could put together algorithms to monitor that. And in the moment you start putting together algorithms to take care of our health, you could, for instance, know immediately the number of people who's having temperature, who's having fever, or the number of people who's having complications with their heart rate, or many other things. Everything is here open to imagination. The more sensors you can think of, the better. Right now we can think of sensors to make urine analysis, to make a number of different analyses that we normally get on a clinic, on a hospital. We can do them at home and with pretty good accuracy. So it's interesting. The situation is changing a lot. Then I met. Well, I remember I wrote this article for Forbes. I wrote this article saying, yeah, the future of healthcare is going to be digital, but not necessarily FDA approved. I don't care if a device is FDA approved or not. As soon as the device brings me enough data, I can calibrate the device. And even if the device is a cheap device that yields the data, but yields data on a continuous, ongoing basis, I can work with that. The algorithms can probably work with that. So I don't really care if they are FDA approved or not. Okay. Then I remember I met Pooja Rao, and Pooja, I was in Netexplo, and Netexplo is one of these innovation observatories I go every year, or not this year. This year has been cancelled in Paris. Okay, it should have taken place a week ago, but everything was being cancelled in Paris a week ago. So 2 years ago, I met Pooja, and Pooja was a very bright radiologist from India, a doctor. She had spent quite some time working as a radiologist, and then she decided to quit and start working in machine learning. And she started to put together an algorithm to try to detect tumors in medical imaging. in medical imaging is a challenge in itself, because the problem is that you have not only the typical X-ray. X-ray is one image or several images, but a few images. But then you can think about, for instance, tomography, or you can think about many other devices that generate normally many more images, sometimes sliced images. So when you have a huge number of images from someone, imagine you have 20 or 50 images, detecting a tumor, well, becomes cumbersome, becomes, I mean, looking at all these images very similar is boring. And sometimes you might oversee tumors. So this person, she started to ask her colleagues to give her as much medical images as she could get, and she started to develop an algorithm to find tumors, to spot tumors in those images. Well, imagine her colleagues. Her colleagues, first of all, they started thinking, hey, should I contribute my images or not? Because after all, this is an algorithm that is going to substitute something that I'm doing. It's part of my tasks as a doctor. But they also thought, well, if we can improve the detection, that might be fantastic, and I could perhaps spend more time talking to my patients, or doing other tests, etc., just to double check. So she was very persuasive, and she managed to get a large number of doctors, particularly telling them that the whole thing would be open source and available for everyone. And she put together Cure AI. Cure AI is a company, an Indian company, that manages to spot tumors on medical images. So I thought, okay, this is the future of medicine, of healthcare. The future of healthcare would be early detection of maladies, of diseases. If you can detect them early, probably the patients will suffer less, and you will probably also save money from the medical procedures, because you're detecting them early on. Okay, so that's probably going to be the future. Algorithms taking care of us, because you can't have a doctor constantly monitoring you. Okay, so if I think how this has evolved, this is about the importance of learning. How doctors, for instance, have been learning pretty much their whole professional life, and learning a lot, and doing a number of things to improve their skills, etc., practice, etc. But how important it is also to unlearn. Unlearn becomes extremely important, because you need to realize that at some point in time, you're going to be able to gather more data, in real time, and to change the way you conceive medicine. Okay, and medicine will be done in a different way. And this doesn't mean that the doctors are going to be substituted. It means something different. It means that you're going to be doing something that works better. Okay, so if you check how machine learning has been, and the curiosity about machine learning, the number of searches for machine learning has been growing, you see that most of these searches, most of these queries on Google are associated with a number of things like Python, or Coursera, or you see machine learning Python, deep learning, machine learning Coursera, or R programming language, a number of things that give you an intuition that in order to do machine learning, you need to program. Okay, you need to start thinking about programming in languages like Python, R, etc. Okay, so what happens with this? We are talking about something that is for sure going to be extremely important. Here we have Sundar Pichai, the CEO of Google, and right now the CEO of Alphabet, saying something like this. He compares the impact of AI to electricity or to fire. Think about it. Think about the humanity before and after electricity, or before and after fire. And we are talking about technologies, electricity after all is a technology, or fire is a technology, that took a number of years, a lot of years, to diffuse all over the world. Now we're talking about AI, and AI is a technology that is diffusing fast. It's going to be available for, it's already available for most companies all over the world, and it's happening in less than a decade. Okay, so what's the importance of this? If we check out the typical Gartner hype cycle, you see machine learning right now going down the through of disillusionment. If you trust this hype cycle, machine learning would be right now right after the peak of inflated expectations and now going down. But this doesn't take into account that machine learning comes from very, very early on. Machine learning has been, I mean, we've been working in machine learning for a long, long time. I mean, check out one of the co-founders of VML, Tom Dietrich. You have the opportunity to see him this afternoon. I mean, this is his thesis, his dissertation. His dissertation is from 1984. And this was I mean, it wasn't a very mature stage of machine learning, but dissertations were being written about this in 1984. Okay, what happened? Well, the problem in 1984 obviously was that the computing power was not enough. It was very difficult to work with machine learning in those years. Okay, if you check out Tom Dietrich, he's a very, not only a very, very smart guy, but a very interesting guy who's also working in things like, for instance, how to solve the problems with the climate emergency, how to monitor the whole Earth, the health of the Earth, what's going on, temperature, pressure, etc., all over the place, with cheap sensors deployed all over the world, and be able to make policy or management decisions with that. I mean, I'm really in love with what Tom is doing these days, with what Tom is working on these days, and I really invite you to check out his talk this afternoon. It's really interesting. But going back to the 80s, when all these things started, I remember in the 80s, I got my first computer. My first computer was very similar to this one. It was the IBM PC. I got it because my dad won a lottery ticket, and then I asked my dad to give me. I mean, he didn't get rich or anything, but yeah, enough for a few caprice, for a few gifts. So I asked my dad, Dad, I want a car. I was 18 or 19 back then, and my dad looked at me and said, "No, you're getting a computer." And I was like, "What? What are you telling me?" But anyway, I started to play with this computer. What was I doing with this computer? Because this computer ended up being extremely profitable for me, and my dad ended up being some sort of visionary, because he gave me this in the 80s when no one had a computer at home. What was I doing with a computer? With a computer, what I was doing was basically this. I was learning how to introduce, first of all, rules into the computer. And rules were programs. The first programs I started to use, if I remember, if I bring them from the top of my head, would be like Lotus 1-2-3 or WorldStar, later WordPerfect, things like Harbor Graphics. I was using these programs. These programs were a set of rules that were introduced in the computer. Okay. Later on, I started to program myself. I learned a little bit of a few programming languages, so I was able to introduce the rules myself. And then what I was doing is introducing data. Data were things that I was punching in my keyboard. Texts, for instance. I remember that I started to love my computer when I realized I could run a word processor like WorldStar and hand in an assignment in the university where I was, and hand in an assignment that was not handwritten or typed in a typewriter. No, it was there in a word processor with different fonts and, oh my God, footnotes. And my professors were looking at me like, oh my God, this guy's gonna be good. I don't care what the assignment says, but it looks fantastic. And I remember I got a fantastic advantage out of that, believe it or not. I mean, it was differential. And so from these rules and the data I was able to introduce, I was, via classic programming, I was being able to get answers, whether they were a document, a very nicely arranged document, or when I started using spreadsheets, for instance, I remember I started using spreadsheets for genetics. Well, I was getting other different types of answers, like percentages of crossbreeding, etc. It's a number of things. And my professors were looking at me like, oh my God, this guy is amazing. When I was a perfectly normal person, just having early access to a computer, okay? Or I started to do presentations, and my presentations obviously looked much better than the average presentations of the day. I was getting answers. And this was pretty much it. This was the way we learned how to use a computer. What are computers? You put rules into them, you put data, you introduce data, and you get answers. What happens if we start changing that equation and we start to do something like this? Okay, we introduce data in the computer, and along with the data, we introduce the answers that this data gave us previously. in previous moments, okay? And then we let the computer understand what's going on with these patterns, with this data. Okay? Since we have been labeled all the data, we can tell an algorithm to figure out what are the data telling us. So the computer derives the rules. And when we know the rules, we can apply the rules. We can, for instance, run predictions or anomaly detections or a number of things. Okay, so this is the main difference that we have to bear in mind. This is, from my perspective, the true definition of machine learning, understanding the changing role of the computer. Because we've been using computers for a long time right now. We now use computers in every aspect, in every area of the company, but we are not yet thinking along these lines. Okay, so what I want you to figure out is what changes when you can do something like this, like this XKCD cartoon. Okay, oh my God, you organized your photo archive. Now you can search, for instance, and you can tell your phone to find you pictures of this person. Find pictures of my wife, find pictures of cats, find pictures where I have with a sunset. Okay, and you can do it right away. Okay, in order to do that, what's required? Okay, because if you try to program via classic programming an algorithm to detect what is a cat or what is a dog, imagine, that would be crazy. Imagine the number of conditionals that you have to put together in order to ensure that something is a dog, that a picture contains a dog. Dogs can come in many different breeds, in many different, so it's extremely difficult to convince, to program all the things that allow the machine to detect a dog. What happens if you start introducing pictures, and every time you find a dog in the picture, you tell the computer, there's a dog here? The computer ends up figuring out what is a dog, and it ends up working much better. Okay, so the thing is, interestingly enough, what you're doing here is manual work. You have to undergo through all the work, through all the job that involves labeling each and every picture where there's a dog in such a way that the machine can detect dogs, can learn the patterns. Okay, so this generates a lot of questions and a lot of myths. The moment you show someone an algorithm that can detect pictures of your wife or yourself or a sunset, it looks like magic. It looks like, oh my God, magic wand. And no, it's manual job. It's someone labeling, the same way it happens with our home devices like I don't know, Google Home or Amazon Echo. They learn, and they learn by someone labeling all the things that the machine hears. Okay, and it's the only way to do it. Labeling a vast amount of data. It's the only way you can do it. Okay, so what happens? You see this and you think like this is magic. You start to think about, and many myths emerge from there. The first myth is pretty clear, is that in order to do machine learning, you need a very smart person called a data scientist. You need to start hiring data scientists, and data scientists are this type of people who are, I don't know, very smart or very crazy, and they wear a white robe, and they are as expensive as, I don't know, football players. Okay, so many companies start thinking that if they want to do machine learning, they need data scientists, and data scientists are difficult to get. Okay, so let me recommend you. I found this article, Francisco Martin. He was the one recommending me this article, and I loved it. And the article says, this article by Casey Korikoff, it says, okay, let me tell you that this is different. If you want to make bread, okay, if you want if your company wants to make bread, what type of people do you want to hire? You hire people that knows how to. If you're opening a bakery, you want to hire someone who's an experienced baker, and you want to have people with that expertise making bread. In order to make bread, you will need an oven. Yes, you will need an oven, and you can make decisions on which oven you want to buy. But probably you're not going to start hiring people who can make ovens. Okay, so making ovens is a totally different business. It's electronics, it's appliances, it's a totally different set of expertise, what you need there. So you have to make a decision. Are you in the business of making bread or making ovens? And that's going to make a whole difference. So many companies are hiring data scientists to do something, I mean, because they feel they need a sophisticated instrument and they are trying to build that instrument. What are we going to do in our companies? In our companies, what we're going to do is, first of all, getting a lot of data. We'll see that data has its own economics. But first of all, put a lot of data together in such a way that an algorithm can understand it. So it cannot be in the typical database. It has to be isolated in independent tables, etc. This is going to take you a while. Okay. So first of all, put together your data. Then start isolating cases that are representative, that represent trends or patterns, etc. And from this data, you will derive knowledge. Then what you will do is start putting the dots together, okay? And when you put lines in between the dots, and you start to gain experience. And from there, now that you know the rules, you have derived the rules, the patterns in the data, you'll be able to get creative and start joining the dots in different ways, okay? And by that, you will master what's happening with your data, and you'll be able to run predictions or to find anomalies or a number of other things, okay? So what happens? Well, basically what you're doing is, first of all, taking a glimpse of your data, then trying to model your data, and then be able to run predictions and to find out to what extent your model fits the data that you keep generating, okay? So data if you think about data has its own economies, and the economics of data are different. In many cases, there's a myth that you need a crazy amount of data. Well, sometimes bringing more data, well, data does not respond to economies of scale or network effects. It's different. So sometimes accumulating more data over time is not really something that improves your analytics. Sometimes it's the opposite. Sometimes it brings noise or more storage costs or more processing or analysis costs. So for some reason, we start to think about, hey, I need to hire computer scientists and data analysts and this type of people. Okay, I'm going to feed the machine. The machine is going to turn into, an intelligent machine. And here comes another myth, the Terminator myth. I hate this one. I particularly hate this one because part of my job is obviously talking to, journalists. And whenever you start talking to a journalist about machine learning or artificial intelligence, he or she immediately goes and illustrates the piece of news with a Terminator. I'm starting to hate Terminator, even though I loved the movie. So the Terminator hypothesis is something that is extremely wrong, because what we are seeing here is the machines are not thinking. Machines are doing mathematics. Machines are finding trends, are doing statistics, but they are not thinking. The idea of a machine thinking is totally different. So if you start thinking about a machine trying to find for Sarah Connor in the telephone guide, and then finding Sarah Connor and then shooting Sarah Connor so that she doesn't she doesn't have a kid and all that, that's crazy. I mean, forget it. Get real. Get real. Please park the Terminator hypothesis once and for all. And this is one of my successful articles on Forbes. And I was telling companies here, hey, don't think about machines thinking. Forget about that. The machines are not going to think for a long, long while. The machines are going to be able to run algorithms to mathematically find patterns, and they will give you the opportunity to analyze those patterns. But they are not like robots that are going to kill us all. This is not going to happen, okay? So put all these myths together. What happens if you check out, for instance, articles like this, an absolute beginning guide into machine learning, okay? What is this? Okay, what this is basically the idea that in order to start with machine learning, you have to get into, look at this. First of all, first step, find a programming language, Python, R, SQL, you name it, okay? Second of it, learn basic math about algebra, calculus, probability, and statistics. Oh my God. So first of all, I need to tell a manager to start programming. Second, to go back to his or her notes, class notes on the statistics and algebra and calculus. Then go and do the Andrew Inch course on Coursera. Okay, not bad. And then learn Scikit and learn library, and then read this book, and then a cheat sheet, and then give me a break. What is this? The moment you tell managers that they have to do this, they look at you and they say, you're crazy. I'm not going to do all that. Okay. And do I need to do all that in order to, do I need to learn TensorFlow? Come on, TensorFlow, according to many people, sucks. It's a programming language that sucks big time. So even if you start learning all that, chances are that you're not going to be able to put anything in production, any serious program in your company for years. So that's crazy. So what happens with this type of things? We need to understand that this is what's happening. The phase when data analysts were putting together machine learning projects is long gone. These guys were creating the tools, and now the tools have been created, and what we are doing is machine learning as a service. You basically upload your data into the cloud, and you analyze your data there with tools that are like the one you're going to see, like BigML. Point, click, open a menu, drag, drop, point, click. That's pretty much it. So in a period of time, we will be doing machine learning like a commodity, like you open a faucet and the analysis come, and that's it. Okay, so this is the change in perspective, and it's about innovation, right? And learning from what we used to think machine learning was, and learning that what we need to understand is that in order to put together a project like this, Amazon spent like a year since they first opened the store, using the store only for their employees. Only their employees were being able to shop there. Why? Because they were generating data and iterating, finding all the different anomalies, possibilities, what could happen if two people go together, if you go with a kid, if you pick up something from a shelf and then you put it back in a different place, what could happen? So this is the phase, accumulating data, that is going to take you longer. And in order to do something like that, you need to think about your value chain and think in which points, in which steps of your value chain you can bring value. You need to become a hacker, but not a typical hacker that programs. No, a hacker is anyone who has an expertise on something. Most of you here in the audience today know more about your value chain than anyone else. Obviously more than myself, I'm just a professor. Okay, so you know your value chain pretty well. Think like a hacker, apply a hacker psychology, and start thinking in which points of your value chain you can bring value with machine learning. Forget about programming and courses and books and all that. Just think of your value chain, in which steps of your value chain you can do something. You can apply machine learning to bring value. And then face the real truth. And the real truth, and I make the font, I made the font like 200 points this big, because it's a real important truth, and you're going to see it several times across this seminar. Okay, is this one? Is that it's going to take you 10% of the effort to define what you want to do, and then 80% of the effort to go through collecting the data, transforming the data, and feature engineering what you want to do. That's the big thing where you're going to spend most of the time, and it's boring, by the way. But then comes the nice part, and it's modeling, evaluating the data, doing predictions, and measuring the results. And that's not that much of an effort, particularly thanks to tools like BigML. This is the reality you need to bear in mind. So basically what you're going to do once you have your data together, not only your data, but also perhaps public sources data, who knows, the weather, data about the weather, if you think it's going to influence your analysis, okay? You put all this data together, and you're going to start doing something like this. Mixing your data, okay? Playing, when I say playing, okay? By picking a different analysis and now trying a different technique, etc. And now I'm going to try a logic regression, and then I'm going to try a random forest, and then I will try deep learning, and checking whether the results, the answers, fit the data. And that's amazing. The moment you start doing that, you love it. because you realize that it's, first of all, it's easy. Anyone can do it. Okay, even a manager can do it. Sorry, managers. Okay, so what happens? It's something that you can put into production real fast. So the whole cycle is changing. And now when you start thinking about having machine learning, putting machine learning in a line on your resume, this line that everyone wants in his or her resume these days, it's becoming easier because you can do it. You can learn that real fast. Okay. You can, for instance, become an AI master just by playing. You can play with different algorithms. There are algorithms that allow you to use your webcam to train a visual recognition algorithm. There are many different things you can do to learn what can you ask from machine learning. Okay, so it's becoming much easier. Okay, here's an experiment running in Finland. Finland put together a course of machine learning, but a very easy course with no programming or anything, just to get people, the general population, to understand what can they ask from machine learning. If you check out Elements of AI, this course, this is a totally different course, and its goal is to demystify machine learning. So the moment you start demystifying this type of things, you can do many things. These are elements of the course, and you don't see here very complicated algorithms or books, or forget it. It's just to understand what can we ask. And this is the phase we are right now. We need to understand what can we ask from machine learning. This is another article that I really recommend you to read, The Business of Artificial Intelligence, and how important it is to understand that over the next decade, AI is not going to replace managers, but the managers who understand AI, what can they ask from AI, will replace the managers who don't understand it, who don't get it. So that's a really important thing, how machine learning will affect your business. And managers, be managers. Think like managers, think about business. Don't think about learning how to program or doing things like that. Try to understand what's the impact of artificial intelligence going to be in the everyday lives of your customers. That's the change I want you to think about. Managers understand change management. Okay, what can we change? I mean, stop being isomorphic. Isomorphism is that principle that leads all businesses to behave the same way. And for some reason, we are isomorphic right now, and every company is trying to hire computer scientists and data analysts and data scientists, etc. It's not that way. It doesn't work like that. You end up working like this, like if someone was winding you up. Okay. So we need to understand the sources of this isomorphism. For some reason, we've been told that machine learning was very complicated. We needed highly qualified people, etc. That's not necessarily true. We can do machine learning just with the right tools and easy and in a way that is even entertaining sometimes. Okay? So what I want you to think about is that you're not going to change things unless you start breaking things. And breaking things is breaking the myths. Do not think that you need highly complicated things. Start playing with machine learning. This is going to require, of course, new skills. Things are not going to be as easy as I said today. There's a little bit of hard work, of course, particularly when it comes to working with the data, compiling the data, but we'll enjoy it. I'm sure you will enjoy it, particularly if you're passionate about your value chain and your business, because it's not as the barriers to entry are not as high as they used to be. And we are talking about a totally different game these days. Okay, so this is pretty much what I wanted to tell you, at least a few parts of the puzzle, or the superficial. I'm standing at the surface. The next talks will get deeper into it, but this is basically what I wanted to tell you today. The simple part of it, the introduction to it, and then if you stay through the whole seminar, you will get many more details on it. So now for doubts, questions, clarifications, or insults, or tomatoes, tomato throwing, anything, please, I'm open for questions either now or later on in the.
Thank you, Enrique, for a very insightful presentation and demystifying some of the core concepts of machine learning. So we have a couple more minutes left. Maybe you can take a few questions. One of our attendees asked, will these machine learning platforms replace programmers? in your opinion?
In my opinion, I mean, what is programming? Programming basically is understanding how to do things like conditionals, okay? How to define variables. First, you start programming by defining variables, then you start doing conditionals or loops, things like that. Well, this is what you do to explain the computer what you want the computer to do. Okay, what happens? Well, probably, and we are starting to see examples now, programming will become very different. And the computer will be able to do a number of things for you, like doing all the hard work, like like framing the conditionals, writing the conditions down, etc. All these things, all these definitions will be probably made directly by the computer. If you play with some things, like there's a little exercise you can do with Google. It's called Teachable Machine. If you find Teachable Machine on Google, it allows you to train your webcam by showing different things to your webcam and then run conditions. Every time I show my webcam my hand, I want this condition to be executed. But if I show the webcam a bottle, it will do a different condition, a different conditional. Okay, so after a while playing with that, you realize that first of all, you're training an algorithm. And that's interesting. It's interesting to do if you haven't done it before. Second, you need a whole lot of data for the computer to be accurately discover whether you're showing it a hand or hand like this, like this, like this, or like this, or like this. Okay, and then the conditions, you don't need to write them. They start working without you writing a single line of code. So probably coding will evolve into something like that.